In this video, I'll show you how I repaired my BetaFPV Meteor75 Pro after the disaster and how I went on to build my very own SpeedyBee Master 3X FPV drone with an F405 AIO flight controller and a DJI O4 Air Unit Lite. Hi, my name is Martin and I do side projects. So let's start with a tiny whoop crash. The short version, I tried to do a fancy move I'd seen on YouTube, the drone disagreed and gravity won. The result was catastrophic. The camera ripped off completely, the canopy cracked and the frame was done for, and the flight controller was hanging by the wires. Even the air unit got damaged, though thankfully just one of the mounting hooks snapped off. Could have been way worse. So, step 1, take everything apart. I carefully disconnected the motors from the flight controller, took off the broken plastic pieces and gave the propellers a proper cleaning, because well, they'd seen some dirt. Then I transferred everything to the new frame. The camera on those drones is held in place using small rubber dampers. They help reduce vibration from the motors and propellers, so your footage doesn't look like you filmed it during an earthquake. Once the camera and canopy were reattached, I double-checked that all the motors and the air unit were plugged into the flight controller. I connected the battery and the drone came alive immediately. I connected to my remote without issues and just like that my tiny whoop was reborn. So naturally after that successful repair I got cocky. I thought, okay, if I can fix one, I can probably also build one from scratch. So I ordered a bunch of parts from SpeedyBee and started my first full custom FPV build. I decided to build around the SpeedyBee Master 3X frame, a 3-inch build that's kind of in the sweet spot between small and powerful. It's compact enough to fly in smaller areas, but still powerful enough to really rip outside. The kit comes with a carbon frame, camera mount, antenna holders, GPS compartment, a battery strap, screws and plastic parts. Basically everything except the electronics. For the components I chose 1507 3600 kV motors, 3-inch propellers, Express LRS receiver, GPS module and the SpeedyBee F405 AIO 40 amp Blue Jay flight controller. This little board is amazing. It even comes with a soldering practice board, which is perfect for people like me who don't want to fry a 60 euro PCB on the first attempt. The controller itself has soldering pads for the 4 motors, the battery and several other components such as the GPS and the ELRS receiver. It also has a plug for the camera system. The whole kit comes with several breakout boards for USB-C connection, 5V power and a voltage controller for the camera unit. I started building this drone by putting together the frame. The arms are held in place by 2 screws each, and on the upper side, standoffs for the plastic parts and the top shield are attached. In the back there's a hole for a connection from the controller to the ELRS receiver. I did a test fit with the flight controller, the receiver and the battery connector that also doubles as a GPS module. I then tried to fit the ELRS controller into its dedicated spot and put the provided antenna into the plastic compartment. Next, I mounted the 4 motors with the provided screws, leaving the cables at the original length for now. I also assembled the cover plate that will house the battery pack. With the major components assembled, it's now time to start soldering parts together. So before any soldering, I cleaned up my workspace. Silicone project mat down, flux ready, soldering iron heated up to 360 degrees Celsius and some lead-free solder on standby. While waiting for it to heat up, I also got some wire. The flight controller comes with this soldering practice board that I use to practice my skills first before going on an expensive controller. I first wanted to prepare the soldering pads by putting down a bead of solder. For this I tried a couple of different techniques and quickly learned the golden rule: flux is life. If you put a bit of flax on a pad first, then heat it and touch it with the solder wire, it just flows perfectly. Without flax, it's chaos, like trying to butter toast with a frozen stick. Same with the wires, strip them, add a bit of flux and pre-tin them with a small bead of solder on the soldering iron. Then, when you're ready to join the two, put some more flux on the wire and the pre-soldered pad, put the two together and use the hot soldering iron to connect them. This way you get a clean and durable connection without too many troubles. I tried this out on the practice board a couple of times until I felt confident enough to go for the real PCB. I started by soldering the USB connector at the back of the flight controller. I again prepared the pads and a cable with a bit of solder. Flux, tin, steady hands, deep breath and success. Pro tip: tweezers make it easier to hold the cables in place. I followed the provided wiring diagram and moved on to the pads for the ELRS receiver, GPS module and buzzer. Because when you lose your drone in the field, that buzzer will save your sanity. The kit also includes a big capacitor, which goes between the power leads. Make sure you get the polarity right, the negative flag is clearly marked on the capacitor. It helps smooth out voltage spikes and reduces electrical noise from the motors. Basically, it keeps your electronics happy. I put the leads through the PCB, bent them so they would stay in place, soldered it solid and clipped off the excess wire. Next came the power leads, thick wires, lots of flux and a general bit of solder. And finally, I prepped the pads for the motors. I then moved on and prepared the ELRS receiver by soldering on the connector. With the controller ready, I installed it into the frame using the included screws. I shortened the cables coming from the motors to just the right length, stripped off the insulation and prepared the wires just as before. The kit comes with some wire guides that can be glued to the frame with some double-sided tape that guides the wires from the motors along the frame to the controller board. I soldered the wires in place. Here you don't need to take care of the polarity of the cables, just any of the 3 cables on any of the 3 pads will do. I repeated these steps for all the remaining motors as well. To inspect the connections, I used a cheap digital pocket microscope to go over the soldering points. They looked alright to me, but what do you think? I then tried to test fit everything together, connecting all the wires, especially with the back module of the drone. I soon discovered though that the capacitor and the buzzer will not fit into the body, so I decided to snip off the part that houses the buzzer to make some extra space. If you also do this, make sure you don't snip any of the thin wires. Now it looks like it fits perfectly. I then also put in the ELRS module, plugged in the connectors and made sure all cables fit into the drone and put in the final screws. With this major part of the drone done, it's time to figure out the camera system. The camera frame kit comes with this camera mounting system that is built for the DJI O3 Air unit. However, since the new O4 Air unit is out now, I wanted to use the cheaper, light version in this build. The O4 Air unit comes with the actual camera, the PCB unit and some screws and dampeners to hold the PCB in place. The cable coming from the Air unit goes straight into the flight controller for power and data transfer. There's only one problem, it doesn't fit the O3 mounts. So, 3D printing to the rescue. I first 3D printed this housing for the camera. It will provide protection and has some holes to fit screws and convert it to the size of the O3 Air unit's camera. This way it will fit into the frame. In order to fit the PCB into the frame, I assembled the frame first and also used some 3D printed parts that I downloaded from the internet. They were not the right fit though, so I had to make my own custom designs and print them out on my printer. After a few iterations, I came up with something that will hold the O4 Air unit PCB and convert it to the size of the O3 Air unit, while also housing a casing for the additional voltage converter that is needed to transfer the right amount of power from the flight controller to the camera system. The holes in the adapter were designed to fit heat-set threaded inserts that take standard M2 screws. When setting them in place with a soldering iron, make sure to keep the iron straight and use some forceps to do some final adjustments to the insert. I also had to widen some holes in the metal frame for the whole assembly to fit. I then put the PCB between the two 3D printed frames, dampened by the provided rubber dampeners. The assembly will then go into the metal frame that will in turn fit into the drone. There's a cable that will go from the PCB to the voltage converter and then to the flight controller. In order to fit the whole system together, I had to exchange the cables going to the flight controller. I also connected the voltage converter before putting it into its compartment. The camera itself goes into the 3D printed camera module, closed off by a backplate. Then everything is finally assembled, just don't forget the antenna. The camera is screwed in place via two rubber fittings that came with the kit as well and dampen vibrations. Finally, the camera unit can go into the drone for good and the backplate can be screwed back into place. With these steps, the major parts of the drone are done and all that's missing are the propellers, which are easy enough to put in place. Always double check motor directions before the first flight. And now it's time for the big test. Power on. And it worked. Looks good, all motors are spinning and we are connected to the remote and also the camera system works. Feeling confident? I gave it a little throttle. Indoors. Which of course was a mistake. The drone shot up, I panicked and my reflexes told me to grab it. Don't do that. Seriously, spinning props hurt. But hey, nothing a band-aid couldn't fix. No, but seriously, never try flying a drone of this size indoors. With all that done, I went back to my mom's place and fired up the drones. The tiny Meteor75 Pro flies great again. though it didn't take long before I crashed it into a tree again. The cat was definitely not impressed. And what about the SpeedyBee Master 3X? This thing absolutely rips. It's fast, nimble and terrifying powerful for its size. I've got a lot of learning to do before trying to fly it through tight gaps, but that's what future videos are for. Whoa! So with this, enjoy some more of my bad flying. If you want to build your own drone, I've linked all the parts and tools down in the description, and you'll also find a link to my printables page where you can download the 3D printed mounts and adapters for the O4 Lite air unit. Thank you so much for watching, and if you enjoyed this video, please give it a thumbs up and subscribe. This really helps the channel grow and lets me keep doing more side projects. So see you next time on Martin Does Side Projects.